Welcome everyone who's joined us today so far for the webinar. I'm just going to give it a couple of minutes just while everyone filters through and before we kick off with the main content. But to introduce and to set the scene, this webinar is part of our New Homes and New Ways programme that's running at the Building Centre currently in collaboration with the Housing Festival. The exhibition is on in our main gallery space on Store Street in the Building Centre until the end of February, officially advertised till the 21st of February, but due to interest and popular demand, we're going to extend it till the 28th. So if you haven't yet been to the exhibition, I'd encourage you to come and visit if you can. If you can't make it to Store Street to London to see it, there is a virtual exhibition online through the programme page as well. So do check that out. So as part of the programme, we've got lots of events happening. The webinar today that you're joined is part of that series. We've got more webinars coming up, and we also have 2 days of summit happening on the 12th and 13th of February in our venue. Tickets are on sale and available for that. So join us in the Housing Festival and lots of our sponsors and guest speakers to come together to look at how we address the housing crisis and solutions available out there to do that. So yeah, the 12th and 13th of February, save those dates, have a look at the tickets on our website and do join us. It's going to be a really special event over 2 days with lots of great people coming together. I can now see we've got quite a lot of you joined the webinar, so let's kick off for today's session. This is a webinar lasting till about 1:45, so we've got about 45 minutes to explore innovative concrete advancements in housing solutions. This session is being organised through the...
I'm going to jump in there because I think that the Building Centre are having problems with their wife
out there. We will, hi Elaine.
You froze for a bit, Laura. Sorry, I've just jumped in, but go for it. Carry on.
Oh, was I dipping out? Sorry, our internet connection. But very quickly, we will hear from Elaine, and then in turn, she will pass over to Dan, and we'll hear from Dan. And then there'll be time for questions from you, our webinar audience. That will be through our Q&A box. You should be able to see that at the bottom of your screens. So you can start to think about your questions as Elaine and Dan are presenting. You can put those into the chat, and then we'll address those to Elaine and Dan together after they have both presented. So I will stop. Hopefully my internet connection will stay, but if not, Elaine's there ready. So yeah, over to you, Elaine.
Fantastic. Thanks very much. I'm just going to share my screen now and let me know when you've got that and you can see that.
I can see it, Elaine. That's all good.
That's fantastic. Thank you. So thanks for that introduction, Laura. And yes, the Concrete Centre are absolutely delighted to be able to be part sponsors for this New Homes and New Ways project at the Building Centre. Housing crisis is obviously a really important issue. It needs to be addressed, and as you can imagine, concrete products and concrete are absolutely fundamental material for construction. So no doubt concrete is going to be playing a part in that solution. And so with that in mind, I'm going to give an overview of some of the innovation that's related to concrete, but I'm going to be followed by Dan, who's going to give us some real life, some related innovation in action. So let me just move to my next slide. Thanks. So my presentation is going to be a real, just an overview. It's not much I'm going to be able to do within 10 minutes because there is an enormous amount of innovation, as you might imagine, related to the manufacture of concrete, but also in construction and in use and end of life. So I'm going to focus on some of that innovation that's related to concrete in general, because it is already either being used or has the potential to be used to build homes in various different forms. So that's going to be my bit of this talk. Now, of course, there is a very wide range of products and concrete solutions available for residential construction. At the Concrete Centre, we provide guidance for their use, including masonry, ready-mix, and also precast and off-site solutions. My role within the Concrete Centre, I'm Director of Architecture and Sustainable Design and Sustainable concrete and its use within sustainable construction is a huge hugely important, of course, and forms a very major part of the work that we do. We've got so many resources. Most of it's free. Hopefully you're all aware of who we are, but if you're not, please do check out the website. We have recently provided a new set of pages on our website called Concrete Compasses. And they're there to try and help direct you to where the resources are. I think one of the challenges is often knowing where to find stuff. So we've got one now called Housing, Concrete Compass, Housing, the link's on there. And what you'll see is a whole bunch of guidance documents there related to all the different concrete construction techniques that are available for building homes, but also technical guidance on how to achieve energy efficiency, use of thermal mass, acoustics, things like that. And we've also got a new CQ focus recently published, bringing together some really good case studies and also technical guidance related to building of homes and residential properties. So please do check that out. So a lot of that guidance, as I said, relates to energy efficiency, but also you can see there's a good guidance there called Masonry Construction Explained that helps with some detailing of how to use masonry for homes. And of course, they're also going to, I know that this New Ways in New Homes is focused a lot on MMC, but of course, if we're going to be able to create the scale of new housing that's needed, all of these solutions are going to have a significant role to play. But of course, if we're talking about new homes, we're talking about the speed of construction and the increase in the number of homes that are required. But we also need to make sure that all of those new homes are fit for the future. One could look at a way of just providing a large amount of sort of temporary or short-lived accommodations. But I think the intention, as I understand it from government, and I think it rightly so, is that these are all new homes that should be quality homes and fit for the future. So if we're thinking about new ways for new homes, that should also include resilience to climate change impacts. It's not something at the moment which is adequately covered within building regulations. And I would argue that that is also, so it's not just speed and number, it needs to be, the sustainability credentials of those homes that are being provided. And of course, this is where concrete and masonry really comes in with its inherent resilience performance with regards to reducing the impacts of what are now recognised increased risks related to flooding, overheating, storm damage and wildfires. But of course, quality and performance and sustainability isn't just there. There's a wide ranging, and we need to be reducing, of course, carbon emissions in new homes. So that's through energy use, but also through embodied carbon. And that embodied carbon piece is as you might expect, a real driver for innovation with regards to concrete. So it's a big area that I'm going to be looking at in this presentation. There is a huge amount of innovation taking place right now with regards to reducing the carbon footprint of concrete. Hopefully you're all aware that there is a UK concrete and cement industry roadmap. It's been around for a few years now. It was published in October 2020, and that was already building on good work that was already in place and in action. There's been some good progress right across from this whole range of these 7 technology levers that have been identified. That's all necessary to achieve beyond net zero by 2050. So far, 53% reduction in carbon since 1990 has been achieved by concrete in the UK. Of course, there's still more work to do. And there's going to be an update on progress published very soon. But you can get a lot of the details about those different technology levers through that QR code on the slide there. Now, as I said, it's impossible to go through all the different action and innovation that's taking place. But I just wanted to draw your attention to this article that was published just under a year ago. But it's still a really good one to look up about the range of different things that are going on within the UK, and you can pick this up from our website. In this presentation, I'm going to run through just 5, probably 6 themes of decarbonisation activity that's going on. So that's one. Now I'm going to start. So we'll do a quick fly through. So the first one is innovation in manufacture of Portland cement. So if those of you who know these things, not everybody does, cement is the main thing that brings the embodied carbon to concrete. So there's a lot of focus on activity related to cement. Aggregates, which are most of what concrete's made out of, actually are incredibly low in carbon and usually locally supplied. So in the manufacture of Portland cement, about 30% of the carbon associated with that is a result of the fuels that are being burned. It's really high temperatures that are needed. So fuel switching is one of the areas of early intervention that the industry have been looking at, and the latest figures that were available in 2022, about 50% of the thermal input was provided by alternative fuels, and that thermal input for those fuels, a lot of them are based on waste-derived fuels, so switching away from fossil. It's not the only area of innovation with Portland cement. The other is in alternative raw materials in the making of it. So that's including waste plasterboard, recycled concrete, waste porcelain, roof tiles, all to reduce those in-process emissions as well. So changing the recipe of the making of the cement so there's less carbon produced in the process. Now, those process emissions are there. It's due to the chemistry of the making of the using Portland cement, and at the moment they account for around 70% of the overall carbon emissions associated with it. So these are going to need to be captured. So carbon capture, use, or storage is going to be necessary to reduce these. Now, a few years ago, this technology and innovation in this regard was seen as being quite futuristic, and a lot of people I didn't really think it was coming off, but actually there has been significant recent progress in this, and at the moment we are on track for the UK's first carbon capture cement plant to be up and running at Padeswood by 2029. So really exciting and really significant progress there as one of those levers for decarbonisation. There are lots of other sites as well that have been identified, and there's a lot amount of international collaboration to develop the technology for CCUS. So the other area is in lower carbon cements and concretes. This is a hugely exciting area of technology. Recently there's been new cements available through BSA 500, so using limestone, which is less carbon, and so that's a different way of blending, if you like. There's different alternatives to reduce the amount of Portland cement by using limestone and either GGBS or fly ash. And calcined clay is a really is sort of hot on the heels of that. There's another government-funded project that NPA have been running. We're looking at UK sources of reclaimed clay, so to be used that are then calcined and used as a potential alternative for expanding the range of lower carbon concretes that are available. Graphene enhancement is another area of interesting use. It improves the durability and the strength of concrete, potentially providing leaner construction, so less carbon. So whether that's in the making of the cement or also potentially as an admixture, there's some really interesting work that's been done by a variety of people across there. And in fact, there's been a concrete floor slab trialled in housing in the UK, as well as some trials being used by some precasters for using graphene enhanced concrete. There's alkali activated cementitious materials, another form of binder for use for concrete, more becoming available. And there's a new flex standard. There's been a new flex guidance that's been provided to help and facilitate the use of these types of cements, which are non-standard, not covered by current concrete standards. But there's also research and some trials starting for different technologies, so different bases for binders, including Ceratec's use of olivine as a raw material. So a completely different technology as a basis for cementitious to be able to potentially be used in concrete. There's also new uses for recycled concrete, so really interesting area of activity. So whether that is crushing that the concrete at the end of its life to tap into its carbon capture potential, enhancing the aggregates for use within concrete, or brand new concrete products or that are being developed, such as that produced by by Cambridge Electric Cement. It's also potentially, there's lots of research going into recycled cement being used as a secondary cementitious material and in the manufacture of new cement as well. So a very exciting area of work going on that's going to reduce the carbon footprint for all concretes potentially, and that would impact on reducing the carbon footprint of housing in turn as well. Another area is innovative industrial carbonation techniques. So that's about actually permanently embedding and that captured CO2 into the concrete as part of the manufacture. It's another area of work. And there's so much more we could be talking about there, but we don't have time. So the third one is alternative reinforcement. Really interesting. If we can get alternative reinforcements in there, there's a real potential for leaner forms of construction. And there's lots of research taking place by MPA members of precast there, looking into getting more slender solutions by alternative reinforcements. 3D printing, everybody, obviously, that's usually the first thing people come to when they say, I'm looking at innovative concrete. It's a completely different way of transforming the way that we place concrete as well as make it. Now, in the UK at the moment, there hasn't been any homes built, or certainly not that I'm aware of. If anybody knows, tell me. But there has been a growing number of printed buildings and homes internationally, including both a prefabricated 3D printing and in situ solutions. In the UK, there has been some trials for some infrastructure. So this really complex bit of concrete that's been installed in Cornwall in 2023, and there's some other inspection chambers and things being manufactured. So it is a really interesting area of evolution, and I'd be remiss not to include it in this talk. But my final and fifth innovation relates to digital technology. This could be AI and machine learning in manufacturing and construction. And I'm not going to go into great detail because actually Dan is going to focus on some of the ways in which the PC have been using this within construction. But it's a really important area and thread of enabling other technologies as well. So whether that is about digital sensors being embedded within the concrete at the point of curing to facilitate early striking of some of these lower carbon concretes. I would like to, and I don't, but not really the time to go into other circular economy areas of interest. But I just wanted to put this one in because, of course, if we are going to be looking at tackling this housing solution, we need to get better at reusing the existing structures that we have right now. And there is lots of really exciting stuff going on in terms of ways in which we can be harvesting existing concrete components, retaining, converting structures, and designing in the first place to enable their longevity or disassembly and reassembly. So it's a really exciting area of research going on as well that can impact on the way that we build homes. So I said that was a very quick fly through. I'm going to, so hopefully you found that of interest. Of course, we've got lots of guidance on the website through various different places. And of course, please do ask me some questions if there's anything else you want to find out a little bit more about. But otherwise, we're here to help. So that's me. I'm going to stop sharing and I'm going to hand over to Dan now. So Dan, if you want to share your screen and come online, I can see you. That's excellent.
Thanks very much, Elaine. I'll just try and share my screen.
Share your screen and I'll let you know when I can see it and I'll hand over to you.
Bear with me one moment.
I can see. That's it. We just need to see. Perfect. That's it. So over to you, Dan.
Okay, thank you very much. So yeah, thank you for the invitation and opportunity to talk today. So as Elaine has alluded to, the housing crisis kind of dictates lots of different solutions, and we're just going to give you a snippet of what our solution looks like and how we bring accommodation utilising hybrid DFMA solutions. So our solution for this is something called a high tower solution, which enabled us to develop and bring high-rise accommodation utilising a kit of parts approach. For those that may not be aware, hybrid DFMA is the blend of a lot of precast concrete, which is what we have historically done, but utilising lots of different materiality as well in order to bring the right solution to the project. And the DFMA is designed for manufacture and assembly, which knits quite nicely into modern methods of construction, or MMC as it's predominantly called, where units are manufactured off-site, brought to site, and then ultimately put together like Lego. And we like to think that traditional building obviously has a place in order to do that, but this is a more modern form of construction which addresses a lot of the concerns that Elaine mentioned, particularly with regards to acoustics and thermals and things like that. So a little bit more about the high tower system specifically. It's founded on a kit of parts approach, as I touched on. So we pick our units from a systemized library. We then utilize digital technology in order to track those units, and we do that throughout the concept design stage into detailed design, throughout the manufacturing processes, And then as they get to site, tracking them, where they go in, where they get installed on site, all of the QA around that, in order to make sure that we've got that golden thread and single source of truth, which I'll touch on a little bit later. As I've already touched on, the thermals and acoustics are a natural byproduct of concrete, and we like to think that we also bring a lot more to the party in terms of air tightness. So passive house standards are something that we can achieve utilising our system, as well as also deploying the system in areas like hospitals or research facilities that have high specification for things like vibration. What we tend to find is that over traditional builds, we're up to 50% faster in terms of on-site activities. It does dictate that a lot more work has to be done off-site earlier, so that sometimes changes things like funding models, and people have to come with the right type of mentality in order to deploy a DFMA solution. But we also are then able to deploy less deliveries to site, reducing carbon footprints, disturbances to neighbours in tight inner city areas and what have you. We have up to 80% less operatives as well. So in a world where we also have a skill shortage within the construction industry, we like to try and de-skill things and do as much in a controlled off-site facility, bring it to site, and then try and put it together with as few bodies as possible, which kind of makes it a more long-lasting term of construction when we're struggling to get the skills out there into industry. Because we are able to refine the designs and do things in controlled environments, we also use a lot less materiality, whereas perhaps on site, materials are brought, things are cast, and then there's a lot of wastage that goes in the skip, a lot of formwork and what have you. We obviously do everything fit for purpose in a controlled environment, which enables us to drive down that wastage factor. And as such, we also get some better carbon credentials as well, which are really maximised when we do get that early engagement. So as a brief overview of what this DFMA journey looks like, we like to get involved nice and early, as I've touched on. That enables us to then talk to the client team, the wider design team, and ensure there's no decisions taken which funnel us down the wrong avenue. And then we're trying to put a square peg in a round hole with regards to a traditional build versus trying to deploy a DFMA solution as best we can. We do a spatial design in order to make sure we're hitting the architectural and engineering intent, and then move that through stage 4 into detailed design, at which point we then produce shop drawings. That goes into a manufacturing environment where those units are then produced off-site, QA'd, and tracked digitally until such time as it's ready for on-site, transported to site in a controlled fashion, in line with the build sequence that has been pre-developed. And then we have the lifting and installation sequencing on site, which is in a systemized approach, enabling us to hit cycle times that often tend to start a little bit slower. But once everybody understands how things come together and the predictability factor starts to kick in, those cycle times increase over time until such time as the building is complete. And then we have the handovers for the end client. And because of that digital twin technology which we deploy and that traceability, the birth certificate that stays with every unit from the spatial design stage right through to the handover stage will track everything from the materiality, who it is that's manufactured it, what's been cast into it, if it's a precast piece of concrete, all of the structural tie connections, if there's any remedials, and then its specific geolocation on site is also tracked so that everybody understands the full history of that unit until such time as it's in its final resting place. And by doing all of that and pulling all that together, we think that we're able to bring construction technologies which are safer, offer better quality in more controlled environments off-site. We know we can reduce times by up to 50%. And when we have a housing crisis that's dictating we need to build and build quickly, we think we're able to deploy it and bring some solutions to that as a problem. We bring added value by bringing other people into our solution, trying to facilitate the follow-on trades, which I'll touch on in a little bit. And because we have the early involvement, that coordination piece with the wider design team also means it's a real collaborative effort in order to maximise the benefits of a project. The predictability itself obviously carries less risk through to development at the project stage, so people understand what's happening day to day, hour to hour, so that you can plan accordingly, which is inherently also a lot safer. And then we're able to drive down those sustainability credentials as well by really refining that design and offering our clients the certainty that they need. So this is kind of, for those that are familiar with it, kind of the REBA stages of work. Most people are familiar with these stages. I'm not going to go into too much detail about this, but the thing I really want to hone in on is that whilst people understand the REBA stages of work, not everybody is aware that there is a DFMA overlay for the REBA stages of work, which are specific to deploying an offsite strategy. We feel it's absolutely key that we get involved as early as possible in order to fully harness all of the benefits of a DFMA strategy, so that we can then go through the develop design, the manufacturing strategy and the on-site assembly strategy with all of the positives that can be deployed from an MMC solution. As I've already touched on with some of these benefits, we do optimize the design. We feel like we can look at other avenues, as Elaine has touched on, better forms of concrete where it's practical. We can look at reinforcing or only providing reinforcement in areas that's required based on the strengths that are required, rather than a traditional reinforcement everywhere that might be to a particular standard. So that enables us to really drive down reinforcement contents. We've got the waste reduction, which I've already touched on. We value engineer, which is often something that is challenging on a project when people are trying to drive down costs or understand how they maximize what they're paying for. And that added value and coordination piece enables us to cast things into our precast products that then facilitate follow-on trade. So we put the openings in our units that allow the ductwork to come through, that have been predefined, fire stopped. We have single risers that get dropped into place, so it's a single plug and play system. And we really do that by buying everybody into the team and being able to get them on board with that DFMA strategy. The real strength of being a hybrid DFMA solution is that whilst inherently precast concrete has an awful lot going for it, one size never always fits all, unfortunately, and we recognise that. And because we don't own any manufacturing facilities, we instead rely on the supply chain and the good relationships that we have. We're able to procure the products that we need and put them in the right place at the right time, so that we're putting our best foot forward for project delivery. So that sometimes emanates in terms of precast concrete beams and precast concrete slabs, but it could also be timber, it could also be composite beams. We're not really hung-strung by doing it one way. We instead look at all the credentials of pulling all of the kit parts together in order to get to the best solution possible. That systemized approach and the predictability that it brings means that we're picking things out of a catalogue that have been tried and tested. They've been through thermal, fire, water, acoustic testing, air tightness and vibration testing, and we're able to demonstrate and validate and verify to our clients that what they're purchasing is fit for purpose. And we have all the traceability throughout the digital twin tracking in order to justify that. The integrated systems, the facades can be brick concrete, coloured concrete, they can be patinated concrete. We're able to install the windows into the panels as well, which obviously gets away from any scaffolding around the outside because it's an integrated part of the system. Integration with the MEP, as I've already touched on, casting things in or facilitating underfloor heating being in place, so it's just tested on site rather than off-site. And then we can drop in whilst we're building things like pods or risers, so that we've got less trades on site. We're not bringing other people in, so the client only has to deal with us, and we're bringing that added value. We're also able to install things like balconies and roofing at the same time, which again just drives down that manpower on site. So as I've touched on, that enables us to get to a place where we're putting the right products in the right place. We're doing it to the right standards. So we have data backing up our solutions, making sure that they're fit for purpose, they're robust. As Elaine touched on, we want solutions that can stand the test of time. And then we're able to track it all and provide transparency to our clients through digital traceability. So just touching on that digital twin visibility, this is something that we've developed in-house because we're absolutely adamant that we don't just want to utilize it for our own benefits. We want to be able to give that transparency to the client team so they understand whether we're on program, where problems might be, but probably more importantly, how we're progressing with regards to the program, so they can start thinking about those follow-on trades in order to reduce the overall times for on-site activities. And we do that using a system called Winomia, which takes elemental pieces of the overall structure and then tracks them throughout the design process, throughout the manufacturing process, and throughout the on-site process. So in this instance specifically, we can click on one unit, and then we can have the full history of that unit with regards to the journey that it's been on through its manufacturing and design process until such time as it gets to site. This is all done in a digital twin. So as people are quite familiar with 3D technology these days, you can rotate, you can zoom in, you can find the unit specifically you're looking for, you can click on it, it will expand out, it will give you imagery with regards to that journey that it's been on, it will give you all the details about it. And then it can give all your documentation that sits behind it as well. So whether that's the quality control, the photos, or the sign-offs, just to validate that it's ready to come to site and can be installed. And that's the full digital twin technology throughout, as I say, all three parts of the project. So you've got your design, your manufacture, and your construction. And we really feel that in order to do that, if ever we need to come back and find information through O&M manuals, rather than trying to find paperwork or individuals, it all resides within a 3D environment where people are free to go and find that information, whether it's design related, quality related, or structural integrity or fire related. So all of that enables, we've got a single source of truth which aligns to the gateway 2, and making sure that everybody understands where they're going in order to find that information they require for their project. It's visualized, so it's easily accessible. And throughout project delivery itself, it gives real-time insights and that visibility client side, so people can understand how their projects are progressing. And all of that enables us on site to have a comprehensive management tool for understanding where we need to focus our attentions at any given time. Just a few working examples now. This one is a project that has already been delivered. The video on the right-hand side is really demonstrating those cycle times that I spoke about with the repetitive nature of things being installed. You'll be able to see the core in the middle, and you can see some pods being dropped in with that added value piece. But this is a high-rise residential scheme called N06, which is East Village in London. This had over 5,000 components and took only 24 operatives to build. And it delivered 524 apartments. And over the original scheme, which was an in situ scheme, the client confirmed that we were 30% quicker than if they had gone a traditional build solution. Again, this is another residential scheme. It's currently being built and we're just completing it down at Brent Cross. You can see the various different facade types that we've got on it. So this is really us being able to maximise the architectural intent that the architect was trying to achieve. And as we pan around to the right-hand side, you can see more traditional builds on the right-hand side versus the building on the left-hand side, which is ours, where we don't need external scaffolding, we don't need the vapour barriers, and we don't need brick slips being installed after, because that's all part of the integrated solution. This was a 10-month programme. Again, only 23 operatives being delivered on site. It was NHBC warranted, so we went through a lot of testing with regards to air pressure, wind, water, again, as Elaine touched on, making sure that it's a robust form of construction that the client was looking to procure from us. Again, another project in the centre of Wembley. We've got the Wembley Arch in the background. This is five towers that we're currently delivering. It's a 10-day cycle typically for being able to go from level to level. So we've really refined the ability to build with speed and certainty. And we're on site for about 23 months, installing just over 17,000 components. And then finally, just a bit of a digital representation there on the first image, and then a cycle showing how we've delivered a project called Silvertown Plot 6. This encompassed some affordable accommodation as well as some shops and office space and what have you. So there's lots of different ways that we can try and answer this housing crisis, and we've got a lot of solutions in hand and innovation that's ongoing in order to try and do that. And that's me. I'd be more than happy to take any questions. Thank you for your time.
Thanks, Dan. I think that was brilliant. Lots of really good stuff there. I think Laura might have dropped off the screen, so I'm going to be. I think it's going to be you and me having a chat about this and seeing if we can answer any of the
No
questions
problem.
that have come through. So I'm just going to have a little look. It's very impressive when you just add up the number of homes that were just on those 3 projects that you talked about, and therefore how fast they were being delivered, as well as that quality that we were talking about before. Yeah, that's very impressive. So there are a couple of questions in here. So somebody has asked about the challenges and opportunities for DFMA, and but they're specifically asking about the research challenges. So I'm not sure if that's related to what the research is, but there obviously are challenges and there are opportunities. So if you were going to say, if you were going to try to advise somebody who was thinking about doing it right now, what would be the first thing you would say to them in terms of a way of limiting or overcoming some of those challenges of implementing DFMA on a project?
It's a really good question, and it's a question that gets asked quite a lot, in all honesty. And because it is a relatively new form of construction, I think the biggest hurdle that we have to overcome, Elaine, is a change of mentality. As I touched on, it sometimes dictates that people have to take decisions a little bit earlier. Funding models have to change. People have to spend cash at a point in time where they're not really used to spending cash, which probably brings with it a little bit of uneasiness. So the best thing that people can do in order to try and deploy it is bring people in early. Make sure that people understand exactly what a DFMA solution entails. What does the roadmap look like? When are they going to be needing to take decisions? When do they have to get their MEP suppliers on board? When do they have to procure, their pods? And when do they need to make sure that they've got the gateways in place for high-rise structures versus all of the design work that has to be done beforehand? Because sometimes some people set off down a path and it's a little bit too late, and you're not able to facilitate unlocking all of that added value. So I think early engagement is certainly the best way to overcome that.
Yeah. So is it too? One of the questions here was asking: is it too late once people have got planning? So obviously, optimizing, getting in early is going to make them best efficiencies. Like everything, most sustainability solutions, everything is if you engage early and make those fundamental ones. But presumably, it's still possible if somebody's got planning permission to be able, because often that planning permission is, layout and facades, but there'll be less efficiencies, or it just takes more time to then evolve it to become a DFMA solution. What would you say about that if somebody came in at that point?
I think that's probably a fair assessment, Elaine. You can almost imagine a sliding scale of the amount of efficiency that a DFMA solution can bring, and if you get us involved really, really early, there's going to be a high degree of efficiency and value that we can bring to the project. If it's gone through planning, and it's gone through planning based on a traditional build, and then there is some reverse engineering in order to then turn that into a DFMA solution to then start progressing again, then by virtue of having to do that, it's not quite as efficient as it might be. But going back there 5 or 10 years, we were usually being contacted with solutions that were quite well developed that we would then turn into an offsite solution. Whereas the dial is very much turning now, and people are getting involved early, and we're not having to reinvent the wheel and try and do square peg round hole, as it were. Instead, we're just setting off with the end in mind and knowing what we're trying to hit, which enables far greater rewards.
No, it makes sense. There's it relates to quite a few of the other questions that come through. People are wanting some more direct comparisons with regards to the cost difference between traditional builds and hybrids, and also wanting so cost, but also speed. But you provided some good there. But I would say that if people want some more detail, they can always contact PCE directly to come into some of these. Yeah, absolutely. There's a few questions here about the sustainability credentials, and saying, well, okay, so this is a fast track off-site solution, but how sustainable is that? And some of the questions are related to embodied carbon. You haven't specifically focused in on what the embodied carbon is of those projects, but I know it's there are, I mean, there's different measures of sustainability, obviously, and I've already touched on performance as being an important one, and whole life carbon really comes into its own with they're using long-term solutions and also concrete and masonry solutions with regards to its end of life and its long durability. Up front, I know it's an area, the Eunomia system, there's some talk, isn't there, about being able to evolve that to be able to count the carbon more effectively.
Absolutely.
I know that's something that has been talked about, but of course, it is, but some of these projects, I presume, have been on the drawing board for a little while now, and there's already, as I was trying to explain, there is quite a lot of fast moving innovation going on to bring down the embodied carbon of concrete as well, to be able to meet those. One of the benefits, which you didn't talk about, so I'm sort of answering the question, but I'm asking it at the same time, is that there is a perception that concrete is always going to be the highest carbon solution, and it's not the case when you actually start measuring carefully. And there was some really interesting work that's done a couple of years ago which recognized that just a precast cladding, if you look at the precast cladding, because as you say, it's doing everything in one thing, it's the structure, it's spanning, it's the surface, it's lean, it's actually a brick-faced concrete precast panel is lower than all the other cladding solutions that were being assessed against it, because by the time you add up all the sort of backing and the steels and everything else that needs to go into that construction, everyone's beginning to understand that actually there's much more compatibility with these things. And of course, I don't know whether any of these homes that you've installed, whether they've been able to be installed without any suspended ceilings, so you've been able to reduce the amount of additional stuff that's needed in there to provide the fire safety.
Yeah, absolutely. We do it in accommodation, but we also do it in things like hospitals and what have you, where simple wins like direct decoration as opposed to having plaster everywhere. I mean, if anyone that goes onto an active site when it rains, you know, there's hordes and hordes of plasterboard that end up in the skip before you even think about what actually goes into the building. And if we just eradicate the need for that, because we're able to bring an off-site solution which has got a superior quality to it, where somebody can just apply a finish to it straight away, then all of a sudden, you know, like for like, those carbon credentials are automatically going to be significantly better.
Yeah, it's how you measure, isn't it? Actually, one of the questions here that, and I missed this in your said that you did note, you said there was something like 239 kilograms of carbon for the Felton Firth project. I think it was on the side there. Maybe you don't know the answer. They were saying, was that just for the structure, and was that A1 to A5? But I'm asking you the question, too techie question for you, or do you know?
I mean, I certainly don't have all the numbers imprinted into my brain, but it will be for the structure and for the bit that we're delivering.
So it would be A1 to A5, and it would be the structure. But if that's different, I'm sure that that they can contact you directly to find out a bit more information about that. Okay, so no, thanks, Dan. This is great. There's lots, of course. What's happening is all the questions are coming in now, and we've only literally got a couple of minutes left. So I'm trying to scroll through to see if there are any common threads that I can pick up for the last question. I guess there are some technical questions about one key one, I think, which is a really interesting, so really key to what you're offering, is this digital transparency. And you talked about the traceability and the data that's available with it. Who manages that digital traceability and visibility after the handover? I think because that's such a key benefit potentially for circular economy and for ongoing maintenance issues and reuse. So I think that's going to be my last question I'm going to ask you.
Well, we see this as an answer to being able to put O&M information that is typically handed over at the end of a project into a digital format that is far more user-friendly and robust and has a much better golden thread traceability running through it. So the same way we would hand over an O&M manual to the client for them to then fit out the project, get it commissioned, and then pass it over to the users, it would be exactly the same story, only we would be doing it in a digital format, and all of the information all of the information would reside within that digital twin.
So the answer is it's managed exactly the same as an OM manual would be managed, with the same people looking at it, but it's in a different format. Okay, that's brilliant. Thank you, Dan. I found that really interesting. It's always, I just think that it's fantastic to look at projects that are actually happening, and the speed and efficiency, as well as the quality of the build, and really as an illustration about how DFMA and MMC can, includes concrete. It's an important part of the solution, and obviously really important from a sort of building safety, fire, all those other resilience issues. Yeah, so thank you for that. I'm going to now, on behalf of Laura, whose internet I think must have completely dropped off, she did ask me at the end to say thank you to us both. So thank you to us both. And also to thank everybody for attending. We had a good audience there, and thank you very much for your questions. Please do, if you haven't yet engaged with the New Homes in New Ways exhibition, please do come along to the Building Centre on Store Street in London to have a look. As she said, I think Laura said it's open until the 28th of February. And please do engage with any of the remaining events that the Building Centre are running. And of course, I'm going to do a final plug and say, please do make sure you engage with the Concrete Centre and come onto the website and find out what we're doing, and talk to PCE about their projects. So thank you very much. Thanks, Dan. Thank you to everybody. And
excellent.
I think we're going to end it now. Thank you very much.
Thank you. Cheers.